All right, so we are going to start by looking at this pedigree, and the question has asked us to identify whether the trait is X-linked or autosomal, and then further, is it dominant or recessive? You need to draw Punnett squares when working this out, okay? So I'm going to start with my first family here. I know that the parents are not showing this trait. Okay, so it has to be a recessive trait, whether it is X-linked or not. Okay, if it was a dominant trait, one of these parents would be showing it. All right, so I've already identified it must be recessive. Now I'm going to see if it's on the X chromosome or not. So I'm going to start by putting in my parents' genomes. I know that a mother will have two copies of the X chromosome, and I know a father will have one copy of the X and one copy of the Y. Now, if our trait was being carried on the father's X chromosome, he would be showing the trait. Okay, so it's not. He's fine. It has to be carried on the mother's second X chromosome because remember, we've already identified it is recessive already. Okay, so it has to be carried on the mother's. Now, we're going to work out the probability of this family having a daughter and a son that is infected. So XX, daughters should come out fine so far. XXH, XHY. Okay. So it is possible to have a son that is infected, and that has happened, but not all sons will be infected, so that's promising. But it is not possible to have a female or a daughter that is infected, okay, because they always have a good copy of an X. So this would not be possible if it was an X-linked trait. Therefore, it must be autosomal. So it must be carried on a normal chromosome. Now let's work that out now, okay? So our mother is obviously a carrier. Our dad is also a carrier. All right, what are our kids going to have? Okay, so they are definitely able to be infected. So this is an autosomal recessive trait. All right, let's try another one. So same thing here. We've got a mother and a father. Neither of them are showing the trait, so it must be recessive. Now let's just find out whether it's X-linked or not. We have a pair of female twins here, okay, but only the males are being affected, which is interesting. So let's start with it being X-linked. Remembering it's recessive, so the mother has to be carrying it. Otherwise, the father would definitely be showing it on his infected X. His Y is fine. All right, let's look at this. So females are fine. They are not infected. Okay, but males can definitely get infected. All right, but not always. So there is the possibility of it being, I suppose, X-linked here. Now, the fact that there are only males in this pedigree that is X-linked would suggest to me that it is X-linked, okay? And I would be inclined to write that answer and explain that reason. If it was autosomal, out of 4 children, all right, both parents would have to be heterozygous and a carrier. Okay, out of 4 children, we would see a quarter of them infected. So we might only see one. Obviously, we could see the twins with that, but it wouldn't be likely that we would just see only the 2 sons. So it is X-linked recessive. And one more. So same process here. We decide whether it's recessive or dominant first. I would say just by looking at this, it appears in every single generation. Therefore, it's most likely dominant. But we will explore that. Okay. If it's dominant, our parents have to be carriers for a recessive allele because we do have children without the trait. Let's see if it's X-linked first. So just start with any family really. We'll go with this family here. So we've got a dad who is infected with a dominant X. So we'll put a little H next to it. And we've got a mum that is not infected. So she must have 2 recessive X's if it's X-linked. Okay. Now, here we have got all females in this scenario, if it was X-linked, would be infected. Okay, so it is not X-linked dominant. It cannot be because we've got a female here that is fine. All right, now let's just humor me for a minute and see if it is recessive. If it is recessive, the dad will still have it. He'll just be carrying a recessive X, and it's likely that the mum could be a carrier. Who knows? All right, so one daughter might have it and one daughter might not. Well, that has worked out actually for this scenario. All right, so let's take another family. This is where we'd go to a different family and just see if that was correct. Okay, so the dad does not have it, but the mum does. So she would be carrying 2 copies of her X, recessive X. All right, they've only got daughters, so we don't really need to worry about the males if we want to speed it up. But in this case, no daughters would be infected. But we can see here that one daughter is infected. Okay, so it cannot be X-linked, recessive or dominant. We have ruled that out. So it must be autosomal. And then you just have to check whether dominant works. All right, we've got a mum who is showing the trait here. And we've got a dad who is not showing the trait. What are the likelihoods? She's clearly got a daughter that is not infected. So that's how I knew she was heterozygous. Okay. 50% chance of having infected offspring and non-infected offspring. Done. All right, it works out there. We'd have the same case here. It works out there. We'd have the same case here. It works out there. So it is autosomal dominant. Just remember, you need to go through all your options when looking at your pedigrees, and you need to use the Punnett squares to help you. Okay, I hope this has helped a little bit. And yeah, see you later.